All right, so we're starting Unit 3 today, and not all of your teachers have started Unit 3, but that's okay, because they will be very soon. It's just more quadratic equations. How can I tell that this equation up here is a quadratic equation? What about the equation makes it quadratic instead of linear? That's right, it's a square. So if your variable is squared, that tells you that you have a quadratic equation. And sometimes if you have x squared or t squared, but you don't have a regular x, then you can just solve it by getting the squaring by itself. And that's what some people did down here for problem 3. But let's just read it over real quick. The following equation models the height of a water balloon falling from the top of a 144-foot building. And t is the time and h is the height. So you took the 1 second and you substituted it in. And then you use the calculator, and what did you guys get? How many feet? 128? Mm-hmm. Okay. So after 1 second, it was 128 feet. And then after 2 seconds, you did the same thing. What did this one give you? Yeah. So you notice that it started at 144 feet, and it only fell to 128 after 1 second, but then after another second, it was all the way down at 80. So it's not going down the same amount each time, and that's how you know it's not linear. It's going down more each time, and that's what happens with gravity. Gravity makes it come down more each time. So then, to find out how many seconds until the water hits the ground, you know that when it hits the ground, the height is 0. So you're trying to make the height 0. And some of you guys did that by plugging numbers in to figure out which one gives you a height of 0. And some people did that by setting the height equal to 0. So you have 0 equals negative 16 times squared plus 144. So if you did it with a plug-in method, just take a second and think about how you would solve this equation. To solve this, what can we do first to get the t by itself? Say it again? I could. I usually don't do that first. It's not wrong though. You could do that. I would normally subtract the 144 first. So you have negative 144 equals negative 16 t squared. And then I'll do what Julie suggested, so I'll divide it. What did you get when you divided that? 9. So we get t squared equals 9. And so a lot of you guys just got to t equals 3 seconds. But is there another number that you can square to get 9 besides 3? Besides positive 3 squared is equal to 9. It could be negative 3 squared is 9. But would that make sense that in negative 3 seconds, the water balloon hits the ground? So mathematically, there's 2 solutions, but because it's a word problem, we take the one that makes sense. Okay? All right, questions on the warm-up there? This is just reminding you what square roots are down here. The square root of a number is a value that when multiplied by itself gives that number. So the square root of 16 is 4 because 4 times 4 is 16. What's the square root of 9?
3.
Mm-hmm. And the square root of 49?
7.
7, good. All right, and then if you get a problem like this, I don't know the square root of 2 and I don't know the square root of 18, but I can multiply them together. So what do I get with 2 times 18?
36.
36 first, right. And then I can do the square root of 36. What's the square root of 36, guys? 6. Good. Thank you.
Miss Walker give you my test?
Maybe.
Okay.
I'll look. Not recently, but I might have it from last week. Okay, and if you have one like this, 3 times root 5 times root 20, you only want to multiply the things together that are all underneath the root. So I'm going to multiply just the 5 and the 20. What does that give me? What's 5 times 20, guys? 100. And then what's the square root of 100? 10. So what's my final answer? 30. Okay. So what you missed was we just did some square roots at the bottom. Square root of 9 is 3, square root of 49 is 7, and then these two we multiplied them together, so we could do square root of 36 is 6. Alright, so we're going to turn the page, and the square roots on the next page are not going to turn out to be just a number, but we can still simplify the radical. Alright, so turn the page, Josh. You can catch up on that one later. Alright, so I used to teach two different methods for simplifying a radical, but now I like a third method more. So you can look back on these two methods here, but I'm going to show you the factor tree method, which I think is the best one. So if you take a number like 56, you want to break it into its prime factors. So you just think any two numbers that you can multiply to make 56. Any two. Try them on your calculator if you're not sure.
28 and 2.
Does that work, guys? 28 and 2? Okay. So we're going to do 28 times 2. And then two numbers that will make 28.
4 and 7.
4 and 7. And then 2 is prime, 7 is prime, but 4 can be broken up into what? 2 times
Do all
2.
the repeating numbers go on the inside or outside?
Anything that comes up twice goes on the outside. So these are at the bottom of the tree. These are the numbers that are my prime factors of 56. Now normally you would write this as 2 to the third times 7. But when I'm doing, when I'm simplifying a radical, a square root, I want to break them into as many pairs as possible. So instead of writing 2 to the third times 7, I'm going to write this. This makes a pair, so that's 2 squared. This one doesn't make a pair, so that's just a plain 2. And that doesn't make a pair, so that's a plain 7. So these are mathematically equal, 2 to the third or 2 squared times 2. They're the same thing. But by writing it this way, it shows me what can come out. Because anything that's squared, the square root and the square cancel. So that can come out. And now it's a 2 on the outside. Just a single 2 on the outside, though. And these two multiply. So, I did a factor tree. I circled the prime factors. And anything that I had 2 of, I wrote as squared. So 2 times 2 is 2 squared. And everything else I just included. And then square root and square will cancel, so that 2 comes out. And then these I multiply here. Okay, I'm going to try another one. I'm going to do 162. That's a tough one. What could I break that into? Try something, see if it works.
3.
That's bigger. I'm looking for something smaller, right? 162 can break. Did you say, oh, 3 and 54? Is that what you said?
Yeah.
Oh, I get you. Okay, that works. I thought you were saying 354.
No.
3 times 54. Okay, how about 54? Can I break that up?
Yeah.
I can. Oh, Josh, do you need a calculator, or is there a spare one in that group for you?
Spare. I'll get one.
Okay. 54, guys, breaks up into what? 27 and 2, that works. 27. Some of you guys are waiting for somebody else to do the work.
9 and 3.
9 and 3, good. And 9. 3 and 3. All right, so everything that's at the bottom, we're going to circle. So since we have 4 3s, technically we have 3 to the 4th, but I like to just write them in pairs. So I would write 3 squared times 3 squared. So I have square root 3 squared times 3 squared, and then times 2. Okay, and the ones that are squared can come out. So they both come out. I have 3 times 3 on the outside, root 2. And then multiply your 3's, what do we get?
9.
What's the full answer?
9 root 2.
9 root 2, very good. Okay, if you're getting this, feel free to work ahead. Okay, 80. What are two numbers that will multiply to give 80? 8 and 10, yeah? Okay, we can break both of these up. What could we make 8 into?
4 times 2.
4 times 2
2 times 2.
and 2 times 2.
And then let's have this 5 and 2.
All right, very good. So I have 2, 2, 2, 5, 2. All right, so I have a 2 squared here, and I have another 2 squared here, and then I have a 5 left over. So square root 2 squared times 5.
So it's 4 squared root 5.
So these two come out. Two times 2 root 5, and like Alexa says, those twos go together to make 4 root 5. Spencer, do you have a question? What's your question?
No, I don't have a question.
You sure? You're okay? All right. Yeah, take the hall pass. All right, 375. Any guesses as to what number might go into it?
75 and 5.
Maybe. Is that right? 75 and 5? 375 divided by 5. Yep. So 75 and 5 is going to work. And you know what? I'm going to divide that 75 by 5 again.
Yeah.
What does that give you?
15.
15.
So then 5 times 3.
Yep. All right, and you want to circle everything in your last row. Spencer, stay with us.
He's already done it.
Oh, you already did the problem? That's awesome. So those two make a square. This one's left, and this one's left. So that one comes out.
Wait, so you can get different answers?
No.
So 5 squared root 15.
5 root 15 is the final answer. Did you get something different, Josh? No? All right. So these fractions, people generally get afraid of the fractions, but they're actually the easiest problems, because if you have the square root on the top and the bottom, you just do their individual square roots. What's the square root of 9?
3.
And the square root of 4?
2.
2. So just 3 over 2. What's the square root of 16?
4.
And the square root of 36? And then simplify your fraction. So 4 over 6 simplifies to 2 over 3. Good. Okay, so on the bottom, and actually on the next page too, there are some practice problems, 1, 2, 3, and then the next page 4, 5, 6. So I want you guys to try those problems.
Yeah.
Okay, for 32, I think most of you split it into 16 times 2, and then 16 could be 4 times 4, and each of these are 2 times 2. So technically you have 5 2's, which would be 2 to the 5th, but I like to put them in pairs, 2 squared, and one more 2. So those each came out, 2 times 2. This one's left, and that gave you 4 root 2. All right, this one, 4 times 3, 2 times 2. So your factors are 2, 2, and 3, which is 2 squared times 3. So the square root of 2 squared is 2. That comes out as just 2. So you should have 2 root 3 there. Questions so far? Okay, and then this one, a lot of you did 9 times 5, and that's 3 times 3. So your factors are 3, 3, and 5. I have 3 squared times 5, and the square root of 3 squared is 3. So you have 3 root 5. Questions on this page? Okay, most of you made it to the back, so let's see where you are with that. Okay, 125, was that 25 times 5? Is that what you guys got when you broke it up? And then that was another 5 times 5, so you had 3 of these. So 5 squared and another 5. And this one came out and you had 5 root 5. Alright, Josh, see if that's what you got on your paper, okay?
Yeah, it is.
Good. And then these two, because they're both underneath the square root, those are the two that we're multiplying together. So this 2 just comes down, and I have 2 root 36. And what's the square root of 36? 6. So now I just have 2 times 6. Notice like my square roots went all the way away. And 2 times 6 is 12. So that's done. And then this one, what's the square root of 1? 1. And what's the square root of 121? 11. So that was a pretty quick problem too. All right, take a look at your paper, take a look at your neighbor's paper. Let me know if anyone needs help. You finished?
Yeah, I have a question.
Okay. Give me 1 second to get them started and then I will help you. So for this example 1 here, this is a lot like the problem that we did in the warm-up. I want you guys to try to get the x squared by itself and then solve with a square root. And think about how there might be 2 answers, okay? So try that real quick. Get the x squared by itself and... Okay, so you added the 2 and you got x squared equals 9. And then when you solved it, some of you wrote down 3, but then you remembered that it could also be negative 3 because negative 3 squared also equals 9. Like if you're checking it on your calculator, I know 3 squared is 9, but also negative 3 squared is 9. So it could be either number. So when you solve with a square root, like this, you need to put the plus or minus. X is equal to positive 3 or negative 3. They're both right. So when solving, remember to get the squared term alone. Okay, and also remember the plus or minus. Don't forget that. Okay, in example 2, to get the squared term alone, we have to get rid of that 4. How do we get rid of the 4? Divide it by 4. So I have the square of x plus 2 equals 3. And now I need to get rid of that square. How do I do it? How did I get rid of the square up here?
You root
All right, you already said the right answer. You root it, right? You're going to do a square root. So I'm going to do a square root on this whole thing. And I'm going to do a square root here, but remember that every time I solve with a square root, I need a plus or minus. Alexa, is that what you did on your paper? Did you already get the plus or minus root 3 here?
Yeah.
Okay, so then my square and my square root on this side cancel out. So I have just x plus 2 equals plus or minus root 3. And how do I get rid of a plus 2? Minus 2. So I have x equals, now it doesn't matter if you write plus or minus root 2 minus 3, but usually you'll see this term first. You'll see the negative 2 first, and then the plus or minus root 3. Okay? So these two problems are the same in that you have to get the squared part by itself, and then you solve with the plus or minus square root. I want you to take a minute to do these. There is a trick to problem 2 when you get to the end, and we'll talk about that when we get to the very end of that problem, but do your best on 1, 2, and 3. So to get the x squared by itself, you subtracted the 1, you had 2x squared equals 16, and you still had to get rid of the 2. So you had x squared equals 8, and then when you solved it with the square root, you remembered your plus or minus. So you had plus or minus root 8. But then because 8 can be simplified with a factor tree, do that real quick. You have 4 times 2, and then that made 2 times 2. So you had plus or minus the square root of 2 squared times 2. This one comes out, this one. So you had plus or minus 2 root 2. So two different answers, positive 2 root 2 or negative 2 root 2. For this one, you subtracted the 7, and then you remembered to put the negative on the 10, and you divided it by negative 10, and you got x squared equals negative 4. And what does your calculator say if you try to do square root of negative 4? Error. It should, yeah. Okay. So it says non-real answer. If something's not real, what is it?
It happened.
Not in the real world. What's that other world called if it's not real?
Real.
Think about kindergarten. If they said, what's that again? Imaginary, exactly. Believe it or not, mathematicians have a whole set of imaginary numbers. And if you think I'm making that up, your teacher will tell you about it too in a couple classes. But the square root of negative 4 is actually an imaginary number. So the whole set of imaginary numbers is built on the idea that the square root of negative 1 is this imaginary number called I. Okay? And I know. So now we can do the square root of negative 4. You just make it 4 times negative 1, and then you get 2i. So x is going to equal plus or minus 2i.
What?
I know. So things that you couldn't do before, now you can do it. Because we have this whole set of imaginary numbers. So next class, we're going to talk a little bit more about imaginary numbers.
I think I did that before.
That's good. All right, so that was just to kind of introduce that before next class, that this whole set of imaginary numbers exists. All right, now this one, you had to get the square root, or the square by itself, so you added the 2. And then you square rooted both sides. And don't forget your plus or minus. I didn't even leave space for it. I almost forgot it. So I have x plus 3 equals plus or minus root 10. And how do I get rid of the 3? Subtract it. So usually you have the radical second in your answer. So instead of writing plus or minus root 10 minus 3, you write negative 3 plus or minus root 10, like that. Okay? All right, so that's everything that we have that's new, and we're going to work on some homework. If you don't have homework, I will find you something to work on. We could start by working on that factoring packet.